All right, so good day everyone. We are the Group 1 and we are tasked to discuss the Marine Compass. So before anything else, let me introduce myself first. I am the Cadet Erla Bastas. Here with me this morning is Jude Andre Batukan and Magdaleno Aberion Jr. So to proceed, our learning objectives for today's discussion is simply to know the history of the marine compass. Next is to differentiate the true north from the magnetic north. And lastly is to know how to correct compass variations. So the magnetic compass is the most familiar compass type. The magnetic compass was first invented during the Chinese Han Dynasty. That was about 206 BC. During these times, compass was used for geomancy like feng shui, and it was termed, or they called the compass as the south pointers. So eventually, during the Song Dynasty, that was 1,000 CE ago, many trading ships were then able to sail as far as Saudi Arabia that was using the magnetic compass for marine navigations. All right. So between 1400s to 1433, Emperor Chuti's treasure fleet of the Dragon Throne ruled the south of Pacific and the Indian Ocean, a territory that ranges from Korea and Japan to the eastern coast of Africa. So dako ka siyang territory nga girulan, and the device they were using for navigation was mainly the early years invented compass, no? Next, to move on, in 1500s, early 1500s, Pedro de Medina wrote the Spanish standard work Arte de Navegar, or the Art of Navigation on Marine Compass Navigation. So this is a book that shows the art of navigation, no? On how to adequately correct the compass. To move on, so how does a compass works? All right, a compass points north because all magnets have two poles. These poles are mainly the north and the south pole. And the north pole is one magnet attracted to the south pole of another magnet. So they are using the principle of magnetism. So the Earth is a magnet that can interact with other magnets in this way. So this is how the principle of magnetism works, no? So the north end of a compass magnet is drawn to align with the Earth's magnetic field, because the Earth's magnetic north pole attracts to the north ends of other magnets, and it is technically the south pole of our planet's magnetic field. So to further understand our topic, let me call on our next reporter. We have Mr. Batukan.
The next slide will be magnetic variation. So the mariners believe that the magnetic North Pole coincided with the geographic North Pole. Any suggestion otherwise had been denied. It took until the early 19th century to pinpoint the magnetic North Pole somewhere in Arctic Canada, specifically with the coordinates 78 degrees north and 104 degrees west. So from then on, the angle between the true north and the magnetic north Pedro de Medina could be precisely corrected for. So next slide. So this correction angle is called magnetic variation or magnetic declination. So what is magnetic declination? No? So magnetic declination or variation is the angle on the horizontal plane between magnetic north, the direction, the north end of the compass needle points corresponding to the direction of the Earth's magnetic field line. So that was magnetic north, no? And true north, or the direction along a meridian towards the geographic North Pole. So in the next slide, we will do a simple solving problem in correcting a magnetic variation or declination. So next slide. So this is an example of a problem magnetic variation. So as you can see, we have the true north, and we have a magnetic north or declination, which is negative 10 degrees west. And the first example would be magnetic bearing 1 or true bearing 1, which in this example is 165 degrees east. So in order to solve the true bearing, we have the magnetic bearing plus the magnetic declination. So, so we will fill out the we will solve the problem, no? So the first the magnetic bearing, which is 165 degrees, plus the magnetic declination, or this magnetic north given, is negative 10 degrees. Yes, negative 10 degrees. No, so 165 degrees plus the magnetic north, which is negative 10 degrees, is equals to 155 degrees east. So the true bearing 1 is equals to 155 degrees east. So in this next example, we have true bearing 2. So the what you call this? The formula would be still the same. So magnetic bearing plus magnetic declination. So magnetic bearing for the given in this example is negative 45 degrees west. So plus the magnetic declination, which is the negative 10 degrees, is equals to negative 55 degrees west. So the answer would be true bearing 2 is equals to 55 degrees west. So to further explain, the next topic would be Mr. Aberion.
Okay, let's go to correcting for variation. So the overlaid compass roses below illustrate the difference between the true north and the magnetic north with a magnetic variation of 10 degrees west. So we can see it in the PowerPoint that there are two compass roses, that the one pinpoints the true north and the other one pinpoints the magnetic north. So we can see that in this picture that there is a 10 degrees variation west. So next, converting C is equal to CC plus variation, in which CC and TC stands for compass course for CC and TC for true course respectively. So in order for us to convert true course into a compass course, we need to assign a negative sign to a western direction. Note that this makes sense because of the clockwise direction of the compass rose. So next, we had a example. In the previous picture, we had the inner circle is turned 10 degrees anti-clockwise, hence 10 division. So we had the first CC is equal, the compass course is the 235 degrees equals to the true course of 225 degrees minus open parenthesis negative 10 degrees, then close parenthesis. So course of 225 degrees, the helmsman should give an allowance of 235 degrees of compass course for. So now let's converting from compass course to true course. To convert a compass course into true course, we can use the original equation like we did the first equation we had. If we have steered a compass course of 200 degrees, we have to pilot a true course of 203 degrees in the charge of the ratio, or true course of 190 degrees if the variation is 10 degrees west. Why? So if we had a 3 degrees east variation, we need to add that variation to the compass course. So we'll get, if we had 200 degrees compass course, so, and we had a 3 degrees east variation, we need to add 3 degrees to 2, so we have 203 degrees. So if we add x, we need to subtract the 10 degrees west to the 200 degrees compass course in order to have a 200 degrees compass course to steer.
So again, everyone, in this slide, you get to see the tools or a handy tools in converting compass course to true course and vice versa. So that would be all for our report this morning. Good day, everyone, and thank you.